This presentation is comparing linear regression to a logistic regression. I'm Shin Yu and my partner is Abby.
We use logistics regression when we want to predict the outcome variable from predictor variables that are continuous and/or categorical. We use this model because it violates the assumption of linearity in normal regression. The outcome variable for a categorical model must be discrete. Logistics regression uses a log transformation on the outcome variable, which will allow us to model a nonlinear association in a linear way. We answer the following questions by using logistics regression. What is the relative importance of each predictor? Are there interactions among predictors? And how good is the model at classifying cases for which the outcome is known?
The linear regression model is used for predicting and forecasting. It creates a predictive model to predict the observed data with unknown parameters. The outcome of a linear regression model is usually continuous. It can also be used to find correlation between dependent and independent variables. The simple linear regression formula can be used when there is only one independent variable or one explanatory variable. The multiple linear regression takes in more explanatory variables.
This is the logistics regression equation. F of x is the probability that the dependent variable equals a case, given some linear combination of the predictors. Beta naught is the intercept from the linear regression equation, which is the value of the criterion when the predictor is equal to 0. Beta 1x is the regression coefficient multiplied by some value of the predictor. Base E denotes the exponential function.
For a linear regression model, we can measure or test for the accuracy of the model by looking at the root mean squared error or the mean squared error. The smaller they are, the better and the more accurate the model is.
When using the logistics regression model, ROC curves are very useful for evaluating the predictive accuracy of the model. There is also a test in R that will tell you how accurate your logistics regression model is. And now for a live demonstration. First, we will demonstrate a linear regression model. Our example will be trying to determine the price of a house using the features of square footage, number of bedrooms, and number of bathrooms. We will go to Fit Model, select Price as the Y variable, and the other variables will be dragged to construct model effects. The result is 4 graphs. The first graph uses the latter 3 graphs to predict the price of the house based on the 3 features. This may not be a good model, however, because our R-squared value is 0.376. Next, we will demonstrate the logistics regression model. Our example will be trying to determine the probability of someone at a certain age will buy a certain sized car. We will go to fit y by x, and size will go on the y-axis and age will be on the x-axis. The bottom curve represents the predicted probability that for a given age someone will buy a large car. The second curve represents the probability that someone will buy a large or medium car. The distance between the two curves represents the probability that someone will buy a medium car. Thank you for watching.